Hello, AP Statistics students, and welcome to AP Statistics. This is Ms. Skokin, and we are going to get started on our study of statistics. Now, as it turns out, we don't have our textbooks yet, so we're going to start with some notes that will introduce us to the idea, well, several different ideas, concepts, and new vocabulary that we will start discussing even before we do the assigned readings in our textbooks. So by the time we get to the textbooks, we're going to be in good shape understanding what those terms mean. The first thing that you need to do is download the guided notes from Canvas. Ideally, you're going to put those guided notes in Notability so that you can take notes along with this video. However, if you don't have an iPad or don't have Notability, download them into an app that you'll be able to take notes on top of. This will be a PDF, so any type of software that allows you to write on a PDF would work. Let's talk a little bit how we're going to be taking notes this year. With only a few exceptions, we're going to be following these norms when taking notes this year in AP Statistics. Number one, first we'll read the learning targets together so that we know what the lesson is going to be all about. Number two, students will work in breakout rooms with each other to fill out the first few questions in the set of notes for the lesson of the day. Students will be taking notes in either blue ink, gray ink, black ink, or pencil. Then we'll get back together and we'll debrief. We'll make additional notes in red ink and we'll list out the important ideas. Then students will practice the new skills and vocabulary, which will include new types of graphs, new types of analysis methods, and new types of numerical summaries using the Check for Understanding questions, and you'll be able to work on those in collaborative breakout rooms so that you can support each other's learning. Of course, I'm always available for help if you need a question answered. Then independently, students will work on homework, which could be assigned textbooks readings, assigned textbook practice problems, exercises in AP Classroom, in Khan Academy, or in MathSpace. For today's lesson, here are the learning targets. Identify the individuals and variables in a set of data. Classify variables as categorical or quantitative. Make and interpret bar graphs for categorical data. Identify what makes some graphs of categorical data misleading. Calculate marginal and joint relative frequencies from a two-way table. Calculate conditional relative frequencies from a two-way table. Use bar graphs to compare distributions of categorical data. Describe the nature of the association between two categorical variables. Now you notice that some of the words are highlighted or bolded. I just want you to recognize that there is going to be a lot of terminology. We're going to learn the vocabulary of statistics, and you are going to be expected to have a working vocabulary using all of these new terms. For lesson 1.1, we're going to be taking a look at categorical data, and our research question is, how are your favorite classes related? Now, just a reminder, sometimes we use specific words that mean specific things, and very often students want to use the word correlated, but we're not going to be using that because it means something very specific. We'll use it in Chapter 3, but in the meantime, if you want to say that things are related, you can either use the word related or you can use the word associated. So we're going to start by asking, is your favorite elective class associated with your favorite core class? And we're going to collect data. Now, we know we're not in the same room together, so I can't ask you what your favorites are. So I'm going to do some invented data. So let's say out of our class of 30, we have 6 students who have art as their favorite elective, 9 who have music, 7 who have physical education, 4 who have a world language as their favorite elective, and 4 who have technology. Now, let's identify the individuals that we are describing. And you may have thought, well, we're describing students and their preferences, and that is exactly right. Now, the variable that we're looking at is called favorite elective. And when we consider what type of data favorite elective is between categorical or quantitative, it is definitely categorical. Quantitative would be something that we either count or measure. Now, we're going to take a short break from this video because I want you to go to the Statlet. You're going to go to statlet.com and you're going to enter the data from the table that we just created. From there, you're going to be able to make a bar graph and pie chart. So I'm going to write down the commands for you, and then you will be able to go to Staplet, and then once you're done, you're going to draw the bar graph and draw the circle graph in the space indicated. When you get to Staplet.com, you're going to use the very first applet under data analysis, one categorical variable, single group. When you need to add more lines for more categories, you're just going to use the plus key. This is what your Staplet screen is going to look like before you go to begin analysis. So go ahead and fill that out on Staplet.com and hit begin analysis. It's going to give you some options, such as bar chart, segmented bar chart, and circle graph or pie chart. And what you want to do is select bar chart. You also have the option to select frequency or relative frequency, and for now, just check frequency. It's always good practice for students to draw graphs by hand, because on the AP exam, you may need to draw graphs. You will not have a ruler, you will not have any other type of technology other than your calculator to be able to screenshot graphs. So I'm going to recommend that you draw the graph into your notes, but I will be inserting a screenshot of the graph that came out of the Staplet.com applet. And then we go back to the applet to create the pie chart so that we can draw the pie chart and see what that graph shows us. So I've inserted screenshots of the settings for the Staplet, the bar graph, and the circle graph. You should have just drawn in your bar graph and your circle graph. Let's move on to question number 5. It says, sometimes it's helpful to investigate more than one variable. That is definitely true. It helps us to see the relationships between things. Now, it says come to the board and put a tally mark where you belong, but what we're going to do is I'm going to, again, take the kind of fake data that I had collected, and we're going to say out of the 6 students, I'm just going to put a little total column here, out of the 6 students who selected art as their favorite elective, their favorite core class is split between math and English in a 2-to-4 split. For music, the total number of students that we had who selected music or dance as their favorite, and that is 5-to-4 split between math and English. For physical education, we had a total of 7, and they are split 4 and 3, math and English. And for world language, we've got a split of 1 and 3 for a total of 4. And in technology, we also had a total of 4, and they are split 4 and 0. So now what we want to do is find each of the following, starting with the percent of all students who chose PE. So all of the students is the grand total, and that is 30. We also have a total for all the math preference core class, and that totals up to 16. And then the English totals up to, let's see, 14. Okay, so that matches with our grand total of 30 also. Now, let's take a look. The percent of all students who chose PE. What we're going to be doing is taking a look at the PE preference and dividing that by the grand total. So that's going to give us 7 out of 30. We can show this number as a fraction, as a percent, or as a decimal. Next, we're going to find the percent of all students who chose math and art. So we go to art, we go to math, and we have 2. We're finding the percent of all students, so that means it's going to be 2 over 30. And next, we're going to find the percent of students who prefer math that chose tech. So out of the math students, so we're going to use the grand total for the math students, how many of those liked tech as their favorite elective? So the way that we write that is 4 out of 16, which is 25%. Let's add some notes to the work that we've done. I want to take a look at the bar graph first of all, and I just want to mention that in order for a graph to not be misleading, we need to make sure that the scaling is done properly, and that means that scaling needs to start at 0. Also in a bar graph, notice that the bars are separated. That's because the axis, that horizontal axis, is not a number line. And no matter what kind of graph we're making, we need to make sure to always label and scale. When it comes to the circle graph, you can see that we've got the different colors representing the different favorite electives, but we need more than that because we don't have any sense of scale, so we need to put the percentages in there. The percents can be put directly on the circle or can be put into the key. Now, I just want to point out, when I say label and scale the graphs, that here we have frequency, and that means the count of how many students were in each of those different bars or represented in each of those bars. We also have favorite elective listed because that is our variable, our one variable that we are graphing on that bar graph. All right, now let's take a look at the probabilities that we found. We organized all of this data in what we call a two-way table. The reason that it's called a two-way table is because we have two different variables, core class and elective. When it comes to the values that we found, when we found the percent of all students who chose PE, we call that a marginal relative frequency. It's a relative frequency because it's a percent or a proportion and not a count. It's called marginal. I'll show you that in a sec. It's called marginal because we built it from numbers really in the margin on the outside of the table. So anytime you're using the totals and the grand total, a column total, a row total, and the grand total to come up with one of these proportions or one of these percentages, we call that a marginal relative frequency. For the next one, the percent of all students who chose math and art, that and is a super important indicator that this is a joint relative frequency. And the last one, where we found the percent of the students who prefer math, that chose tech. So we used the math total as the condition for our conditional relative frequency. Let's move on to the questions on the next page. As we just said, the table above is called a two-way table. So when it asks us how many variables does the table have, we know it has 2, and are the variables categorical or quantitative? We know that they're categorical. When we're analyzing the relationship between two variables, we often want to know which one would be able to predict or explain the other variable. We could probably argue this one both ways, but we're going to go with the core class could predict the favorite elective. Next, I'm going to have you go back to Staplet.com and enter the data from the two-way table. You've got it in your notes. Once you've entered all of that data into the Staplet, you're going to create a side-by-side bar graph, and you're going to create a segmented bar graph. Then you're going to sketch them below in your notes. This time, you're going to choose, still under data analysis, but 2 categorical variables. When you get to the 2 categorical variables Staplet, it's going to ask you which variable is the explanatory variable and which one is the response variable. This is why we needed to choose between our 2 variables in the two-way table which would explain the other. So remember to put the full variable name in, name the columns and name the rows with the appropriate class names, and then put in the counts from our two-way table. Here's what your screen will look like before you begin analysis. Notice that the settings for the side-by-side bar graph allow you to either graph in frequency or in relative frequency. Again, relative frequency is percents, frequency is counts. So I'm going to graph in frequency for the side-by-side bar graph. When it comes to the segmented bar graph, you only have one option, and that's relative frequency, and there's a reason for that. Just as before, we want to make sure to label and scale. So the only scale that we need is the frequency scale, and we only need to go to whatever the highest number was. 5 was our highest for music, dance, and math, so that's going to be our highest bar. And then we also have the key for the different colors. The other way that you could do that, of course, is to draw directly onto the bar what each of the categories stands for. But we've got one cluster of side-by-side bars for math and one cluster of side-by-side bars for English, showing the distribution in frequency. Again, not in relative frequency. So let's take a look at the segmented bar graph now. In the segmented bar graph, we have again got the labels, scales. This time it's relative frequency, not frequency, and we've got the key for the different colors and what they represent. Again, we have a cluster of values for math and we have a cluster of values for English, but this time we've basically got what amounts to the same information that we would have if we had two circle graphs that were side by side. Because in a bar graph, we typically look at a comparison of parts to parts. In a circle graph, we typically look at a comparison of parts to the whole, or to the 100%, and that's the same thing, the parts to whole, that a segmented bar graph gives us. So we can take a look and we can see now, based on the people who like the core class of math, when we look at the distribution of favorite elective, do we see the same behavior from the math people as we do from the people who favored English as their favorite core class? Or do we see different behavior? And if you remember, that was our original research question. So we're gonna kind of hold that thought for a minute. We're gonna take a look at number 9, and it says, how do the bars in the side-by-side bar graph relate to the bars in the segmented bar graph? I know it may not be immediately obvious because the side-by-side bar graph, we've got skinny little bars, and on the segmented bar graph, we've got kind of wide bars for math. But basically what we would do to go from one to the other is we would take each individual component and stack them on top of each other. So you can see that on the side-by-side bar graph, the smallest number belongs to world languages, the smallest number of people, that's one person. That then is represented here. The dark blue, which is 2 people, is represented here. That's 10% of the total number of people that were surveyed. And then this tall one is represented there. And then the green one, which is the technology people, is represented there. So we're just taking those bars and we're stacking them on top of each other. But instead of using the counts, we're using the relative frequency or the percent of each one. Now, you can see in the English segmented bar graph that the values look pretty much even with each other. The 2 oranges are the same size and the 2 blues are the same size. And that's exactly what you see represented in the side-by-side bar. So again, we just took those values and we stacked them on top of each other. Now, the reason that we use the relative frequency instead of the frequency is because we want to be able to compare the two. And if we don't have the same number of individuals represented for math favorite core class and English favorite core class people, then our 2 segmented bar graphs would have a different total height. We don't want that. We want to be able to compare them, and the only way we can do that is to find the common denominator of percent. So let's compare them. In number 10, it says, is there an association between favorite core subject and favorite elective? If so, describe it. Now think about the wording of this question. If there is no association, no relationship, and people like their favorite elective equally, whether they're math people or English people, then we would see a similar distribution between the math and the English segmented bar graphs. But we don't see that. We do see that the math people have a tendency to have technology as their favorite elective class, but people who favor English as their core class do not. So that means, because the 2 segmented bar graphs look different, that yes, there is an association between favorite core subject and favorite elective. We see some other differences between the 2 graphs. The students who favor English seem to also enjoy world languages and music and dance and art, which might be thought of as humanities type activities. The students who favored math don't seem to like art as much, but still like music and dance and physical education quite a lot, but not really world languages at all. Okay, so that's going to lead us to number 11. If there was not an association between favorite core subject and favorite elective, what would the graphs look like? So again, if there were no association between core subject and favorite elective, or no relationship between those two, then we would see the segmented bar graphs have the same distribution for both the students who favor math and the students who favor English as their favorite core class. Next, let's take a look at the important ideas that we have collected during this lesson. When it comes to categorical data, we have choices when it comes to graphing. We can report the data either in frequencies or counts, or relative frequencies or percents. We will use either bar graphs or pie charts. But there are different types of bar graphs. If we want to compare parts to parts, we're going to use a regular bar graph. If we have to do a comparison, we can use either a side-by-side bar graph or a segmented bar graph. But if we're comparing two distributions, we're always going to want to use percent as the common denominator or relative frequency instead of counts or frequency. Now let's think about what we learned about two-way tables. We know that they're called that because they have two variables. Having the totals can be useful. And we have the ability to calculate various frequencies or various relative frequencies when we use the two-way table. We can calculate the marginal relative frequency using either a row total or a column total divided by the grand total. We can calculate the joint relative frequency by having a particular cell value divided by the grand total. And we can calculate a conditional relative frequency by having the denominator switch to either a row total or a common total. That's what we call the condition. So an example of that would be A over B. And why do we make these different comparisons? Well, what we're trying to do is find if there's an association between the two variables, or does knowing one allow us to be able to predict or understand the behavior, explain the behavior in the other variable. That's it for the notes on this lesson. The next thing that's going to happen is you're going to be working on the check your understanding. What I'd like for you to do, since this is the end of the video, is work on these problems in your notes and check, once you've got them all done, check on the posted notes in Canvas so that you can see how close or how far away you are. Remember to make any corrections necessary on your answers based on the notes in Canvas, but give it a try yourself first. All right, see you back in class.